Welcome to the deep dive. Today we're going to sort of peel back the layers on something that seems pretty simple, just a regular file, maybe sales.csv.
Right?
But we want to uncover the surprisingly complex, very secure, and often hidden journey it takes through a modern data system.
Yeah, it's way more complex than most people think.
Where does it actually go once it leaves, say, your desktop? How is it
Mhm.
kept safe? I mean, really protected, not just shuffled around.
And crucially, how does it change from just raw numbers into something genuinely useful, something that, drives real insights for a whole company?
Exactly.
A great question. Because that sales.csv, it doesn't just sit there quietly. It really goes on this almost epic quest.
Mm.
It's this intricate, secure, highly governed end-to-end journey.
An epic quest. I like that.
Yeah. And our mission here in this deep dive is to unpack all those layers, the technology, the processes, the human responsibilities that all work together.
To make sure the data's right, trustworthy, compliant.
Exactly. All the way from that first raw ingestion right through to advanced analytics, even machine learning.
And we've got a pretty detailed blueprint for this, right? A document that maps out each stage, all the components involved.
We do. It lays everything out.
Okay, so we've set the stage for our sales.csv's big adventure. Let's start at chapter 1, the arrival. What happens the second this file, hits the system?
Right. The journey kicks off at ingestion and storage. And this isn't just like the file landing somewhere. It's critically about how it's handled securely from moment one.
Like a high security delivery.
Precisely. Think of it like a sensitive package arriving at a secure facility. You don't just leave it on the doorstep.
And this first phase, it's designed for secure access, governed metadata, encrypted transfers, clear ownership. It's all built in from the start.
Absolutely. It's not just about moving the file. It's protecting it immediately.
So maybe our sales.csv lands in raw sales year 2025 month, a 7 sales.csv, an external location. And it gets registered straight away in something like Unity catalog.
That's right. It's logged immediately.
What's the key thing here for someone listening? They might think security comes later. Why is it so vital right here?
Because the moment that data touches your system, that's its most vulnerable point.
Yeah.
It's like handling a priceless artifact. That initial contact is where damage can happen if you're not careful.
Right.
Secure ingestion isn't just a good idea. It's the first and maybe the most critical line of defense against, well, data nightmares.
Okay, so how do we do that? How do we make that first touch secure?
We use things called managed identities or service principals. Think of them as like secure temporary digital keys just for systems.
Not actual passwords written down somewhere.
Exactly. This means credentials are never hard-coded into the software,
Yeah.
which makes it way harder for attackers to find them, even if they get into other parts of the system.
Okay.
Instead, the really sensitive stuff, like credentials for connecting to Key Vault or AWS KMS, they're locked away securely in something like Databricks secrets.
Got it. So it's like a temporary digital fingerprint, not a permanent key.
Yeah.
And Unity Catalog, you mentioned that. It steps in here too.
It does. It starts enforcing access policies right away. It says who can read or write to that external location.
And it registers the file, tags it, starts tracking lineage.
Yes, all that foundational stuff.
Yeah.
Even at this early point, networking and encryption are key. TLS 1.2, for instance, encrypts the data in transit.
Like an invisible secure tunnel.
Exactly.
Yeah.
As it moves into the Databricks compute environment. This whole setup right at the beginning, it builds that solid foundation of trust and security.
Fascinating. Okay, so the raw sales.csv is in, it's secure, but it's still raw, right?
Yeah.
The next challenge is getting it structured, usable, a big cleanup job.
Absolutely. This is where we bring order to the chaos. Think of that raw CSV, like a big messy box of Legos, just a pile of pieces.
Right.
We load this raw data into a Delta table, maybe call it catalog.raw. In sales raw. And this isn't just any table. It has ACID guarantees.
ACID. Atomicity, consistency, isolation, durability. Okay, break that down. For our sales.csv, what does ACID actually mean for its trustworthiness? Why is that so important for sales data?
It means your sales transactions are totally solid, like a bank transfer. Atomicity means if you add new sales, either all of them get recorded perfectly or none do. No half-finished, corrupted records.
Okay, no partial updates.
Right. Consistency ensures the data always follows the rules you set. Isolation means if multiple things are happening at once, say one analyst querying sales while another updates it, they don't mess each other up.
Ah, so no interference.
Exactly. And durability means once that sales data is saved, it's permanent. even if the whole system crashes right after.
Wow. Okay.
So this guarantees your sales.csv is always an accurate, reliable snapshot of what actually happened.
That makes it crystal clear why that's so vital. So the data's in this reliable delta table. What's next to make sure it fits our plan for it?
That's where schema enforcement and data validation really kick in. An initial schema, the structure is either guessed from the data or more likely applied from a predefined schema registry, like a blueprint.
Okay.
Then we do critical checks. Are the required columns actually there? Are the data types correct? Is the sales amount actually a number, not text? Are there unexpected nulls?
Like quality control for the data structure.
Exactly. It's like having that Lego blueprint.
Yeah.
It ensures you only use the right bricks in the right places. You can't build a castle with car wheels if the blueprint doesn't allow it.
Makes sense.
And the data usually gets partitioned here too, maybe by year and month, for efficiency. And all the transaction logs, the metadata, that's all managed by Unity Catalog.
So Delta Lake is key here, with the ACD guarantees and blocking bad records. What other tech is working behind the scenes during this stage?
Well, you've got clusters of the compute engines actually doing the work, reading the raw CSV, running those validation checks, writing to the Delta table. And Unity Catalog really steps up its role here. It's not just tracking the file anymore, it's managing the metadata for this new table column definitions, maybe data classification tags like raw or restricted.
So it's starting to label and control access more granularly?
Precisely. It locks down who can even see this newly structured but still raw data. And you still have the networking and encryption controls, TLS 1.2 plus during ingestion and encryption at rest, like a digital safe deposit box using SSE KMS.
And logging everything.
Absolutely. Monitoring and logging capture all the ingestion metrics, validation results, job statuses. It's all there for auditing.
Okay, that makes sense. It really is bringing order to the potential chaos, making sure the data is clean and reliable before anyone tries to use it for decisions. But how does it get from just ordered to truly curated and ready for prime time?
Good question. Building on that clean, validated raw data, the next stage processes and optimizes it into what we usually call a curated data set.
The curated core, ready for action.
Exactly. And what's really interesting here is looking at this curated data from two different but equally vital perspectives. It depends on who you are in the organization.
Okay. This is where different teams might see the same data slightly differently. So from a purely processing view, what happens?
Well, this stage involves deeper data cleansing, handling null values more intelligently, maybe enriching the data, adding extra context from other sources.
And you mentioned schema drift detection before. That sounds important.
Very. Schema drift detection catches unexpected changes. Imagine your sales.csv suddenly gets a new column like customer loyalty score without anyone telling the system. Or maybe the sales amount column changes from numbers to text. Drift detection flags that.
Preventing downstream chaos.
Precisely. And null audits systematically check for missing values in key columns. If you're dealing with streaming data, you'd use checkpointing and watermarking by event timestamp here to keep things accurate in real time.
Got it. And then the data gets partitioned again, maybe optimized with something called Z-ordering.
Right. Partitioning by year month is common. And Z-ordering, say on CustomerID, physically arranges the data on disk so related records are close together. It makes querying much, much faster.
Speeding things up.
Yeah. And finally, this polished, standardized data gets written to a new delta table, maybe catalog.standardized.sales.dd.
Okay, so that's the processing. Now, those two perspectives you mentioned on this curated zone.
Right. First, there's the operational performance management view. This is often the data engineering or platform team perspective. They're focused heavily on optimization, that Z-ordering, file compassion, to keep query performance high.
Making it run smoothly and fast.
Exactly. And this is where Delta Lake's time travel feature really shines for them.
Yes, time travel. That sounds like science fiction, but it's real for data.
Yeah.
How does it guard against mistakes with our sales.csv?
It's incredibly powerful. It's like an undo button for your data lake. Delta Lake keeps previous versions of the table for a set time, maybe 14 days. So if someone accidentally deletes a whole chunk of sales.csv or a bad update corrupts records,
You can just roll back.
instantly, you can restore the table to how it was just before the mistake happened. It's a lifesaver for data integrity.
Wow.
So for this operational view, Unity Catalog is used to apply tags like curated or trusted and enforce very specific permissions. Only authorized engineers can really manage the data's physical structure and performance tuning.
Okay, that's the operational lens. What's the other perspective?
The other crucial lens is data governance and compliance. This perspective is focused on ensuring the data meets all the business and regulatory rules.
So less about speed, more about rules and trust.
Exactly. Here, the focus is on applying schemas based on agreed-upon data contracts, performing strict referential integrity checks, like making sure every sale actually links to a valid customer in the customer table.
No orphan sales records.
Right. And validating against specific business rules. Anomaly detection might also run here, looking for weird sales patterns that could indicate fraud or errors.
And Unity Catalog's role here.
Again, it's central. It enforces role-based access control, RBAC, applies classification tags relevant for compliance, like PII or confidential, and manages the data's lifecycle from a governance perspective. This view is critical for data stewards, compliance officers, folks like that.
Got it. So Delta Lake stores the curated data with ACD and time travel. Clusters do the processing, but Unity Catalog is the central control tower for metadata, access, lineage, tags, rules.
Pretty much. It ties it all together. And underpinning everything, monitoring and logging are capturing transformation metrics, error rates, data validation results, the whole picture.
It really shows how the same piece of curated data serves different critical functions, viewed through different lenses depending on your job, both essential for a quality data product. Okay, so we've navigated the journey from raw file to this pristine curated sales.csv core. Now for the payoff. How does this curated data actually get used? For BI, SQL queries, maybe even feeding machine learning models. This is where the value really comes out, right?
This is exactly where the rubber meets the road. For general consumption and analytics, we typically use optimized SQL warehouses.
These aren't just regular databases.
No, they're specifically designed for business intelligence workloads. They're scalable. They auto-scale up or down based on demand, which is great for managing costs.
Efficient.
And they connect seamlessly and securely to BI tools. Everyone uses Power BI, Tableau, you name it.
How is access controlled here? Can anyone just query anything?
Definitely not. Access controls are strict. Analysts usually get select permissions, but only on curated views, not typically the underlying base tables. And this is where row-level security can be incredibly powerful.
Row-level security. That sounds fine-grained. Give us a quick example. How would that work for our sales.csv?
Sure. Imagine you have global sales data in sales.csv, but the sales manager for Europe should only see European sales. With row-level security, you define a policy basically saying, if your user attribute is region Europe, then you only see rows where the region column is Europe.
So the underlying table is complete, but individuals only see their slice.
Exactly. It's seamless to the user, but enforces privacy and need-to-know rules effectively. Very important for compliance.
That's really clever. What else helps performance here?
Query result caching is usually enabled. If someone runs the same sales report query frequently, the results are cached, making dashboards load almost instantly.
Nice. And for more custom analysis?
Collaborative notebooks are key. Analysts or data scientists can use notebooks for deeper exploration, building custom business logic. These are stored as workspace assets, usually integrated with Git for version control and reproducibility.
Okay, that covers BI and SQL analysis. What about machine learning? How does sales.csv power AI?
That curated sales.csv data is gold for ML. It's used to train predictive models, maybe forecasting future sales or identifying customer segments.
And the quality checks continue.
Absolutely. Feature schemas are validated before training to ensure the model gets consistent. Quality input. Tools like MLflow are essential here. They track experiments, what features were used, what parameters, what the results were.
So you always know how a model was built.
Exactly. Full transparency and reproducibility. Once a model is trained and performs well, it gets registered in the MLflow model registry. It's versioned, approved through stages like staging and production.
And then deployed.
Then deployed, often as a real-time scoring endpoint. And crucially, monitoring continues after deployment. Performance metrics are logged, and drift detection alerts are set up.
Drift detection for models, too.
Yes. If the new incoming sales.csv data starts looking significantly different for the data the model was trained on, that could hurt performance. Drift detection catches that, signaling that the model might need retraining.
Fascinating. So, putting it all together, Databricks SQL runs the queries, Unity Catalog governs access, lineage, row-level security, even permissions on ML datasets and models.
Right. The workspace hosts the notebooks for development. Databricks Machine Learning provides the runtime, the managed MLflow service, the deployment tools.
And identity and access management defines who can do what across the board, from viewing a dashboard to deploying a model.
Exactly. It's this integrated ecosystem that lets insights from sales.csv power everything from dashboards to AI, all built on that foundation of trusted, secure data.
Okay, this whole process sounds incredibly complex, like a finely tuned machine with many moving parts. How does it all actually stay coordinated? How do you ensure step A finishes before step B starts day after day? This must require some kind of backbone.
That's a perfect word for it, an orchestration backbone. This is the automated nervous system that keeps the entire pipeline running smoothly.
And how does that work in practice?
We typically use tools like Databricks jobs. These jobs coordinate all the tasks in the right sequence: ingestion, the raw processing, the curated processing, maybe triggering an ML model scoring run.
So they manage the dependencies between tasks?
Exactly. They understand that the curated step can't start until the raw step is successfully finished. They also handle things like automatic retries if a temporary glitch occurs.
So you don't need someone watching it constantly.
Ideally, no. Jobs can be scheduled run every night, every week, or they can be triggered by events. For example, the arrival of our sales.csv file in that raw landing zone could automatically kick off the entire downstream pipeline.
And what if something genuinely breaks?
Retries are configured. But if a job ultimately fails, notifications can be automatically sent out: email, Slack, PagerDuty, alerting the right team that they need to investigate.
Like a built-in production manager.
Kind of, yeah. And monitoring and auditing are built in here too. Every job run's execution logs are captured. The history is tracked. And importantly, the lineage of what data each job produces flows right into Unity Catalog.
So you can trace data not just through tables, but through the jobs that created them.
Absolutely. You have that full end-to-end picture. The primary orchestrator is Databricks jobs. The compute power often comes from job clusters that spin up just for that job run and then shut down, which is very cost efficient thanks to auto-scaling.
They only use what they need.
Right. Unity Catalog tracks the lineage of job outputs and also enforces permissions on who can run which jobs. And again, comprehensive monitoring and logging record every success, failure, runtime metric, and audit trail event.
It really is the hidden engine, making sure that journey from raw file to valuable insight happens consistently, efficiently, and reliably without constant manual intervention.
Okay, that orchestration piece makes sense. Now let's zoom out a bit. There are these bigger themes that seem to stretch across the entire journey, right? Governance and operational excellence. These sound like the guiding principles, the sort of invisible guardians ensuring everything stays on track.
They really are. They're the cross-cutting concerns that ensure the data isn't just useful, but also trustworthy, compliant, secure, and cost-effective. They're maybe the unsung heroes of the whole process. So let's break those down. First, governance and compliance. What falls under that umbrella?
A lot. Fundamentally, it's about control and oversight. Unity Catalog is huge here, enforcing that fine-grained, role-based access control RBAC we talked about, down to the table, view, even column level.
So you can get really specific about who sees what. Like maybe someone can see total sales, but not individual customer names linked to those sales.
Exactly, that kind of granularity. Another massive piece is data lineage and provenance. Unity Catalog captures that end-to-end trail, from the raw ingestion all the way through curated tables and into the dashboards or models that consume it. You always know the data's history.
Audit trails.
Absolutely critical. All access events, who queried what when, what schema changes were made, it's all logged and can be exported for audits. Then you have data retention and deletion policies, configured within Delta Lake and managed via Unity Catalog, ensuring data isn't kept longer than necessary.
And meeting external standards.
Yes, ensuring adherence to regulations like GDPR, IPR, SOC2, whatever applies. That's verified through consistent policy enforcement across the platform.
Okay, that's governance. What about operational excellence? That sounds more like efficiency and performance.
It is, but it's tightly linked to governance. This includes things like continuously monitoring cluster performance and optimizing configurations. Logging usage and auto-scaling metrics helps tune performance and track costs.
And you mentioned cost tracking before.
Yes, a key part of operational excellence is cost attribution. Using tags to link resource usage clusters, storage directly back to specific business units or projects. So you can actually see the cost of running the sales.csv pipeline for the sales department.
Connecting the dots between data work and business value.
Exactly. Metadata governance is also part of this, using Unity Catalog to manage ownership, classifications, and the defined lifecycle stages: raw, standardized, curated.
And time travel fits here too.
It does. From an operational perspective, having those historical snapshots, maybe 7 to 30 days, in Delta Lake, isn't just for compliance audits. It's crucial for operational recovery, rolling back bad updates quickly.
Right.
And finally, just good workspace organization. keeping notebooks, workflows, models organized in shared folders, enforcing permissions consistently, integrating with Git for collaboration and version control. It all adds up to a smoother, more efficient operation.
So the key components cutting across both are really Unity Catalog as that central control plane, identity and access management for users and groups, Delta Lake providing versioning and time travel, and the overarching monitoring and logging system.
That's a great summary. These principles and tools work together to make sure the sales.csv journey isn't just technically possible, but also secure, compliant, efficient, and fully accountable.
Okay, we've covered the incredible journey of sales.csv, the tech, the principles, but a huge piece of making complex systems work is knowing who is responsible for what. How do you manage that?
That's where a framework like RACI comes in. It's absolutely crucial in these complex data platforms.
RACI responsible, accountable, consulted, informed.
Exactly. It helps clearly define the roles and responsibilities for different teams involved. You might have a data platform lead, a data engineering team, security and compliance, maybe a data science enablement team, and of course the business unit stakeholders.
So let's look at a few concrete examples from our source material. How does RCI apply to, say, Delta Lake itself?
Okay, for Delta Lake standards, how tables should be configured, best practices. The data platform lead is typically accountable. They own the overall standard.
But who actually builds the pipelines using Delta?
The data engineering team is usually responsible for that, actually implementing the ingestion and transformation jobs that write to Delta tables, like our sales.csv pipeline.
And security.
The security and compliance team is accountable for validating that the data stored in Delta meets all the encryption and compliance requirements. They sign off on it.
Got it. What about Unity Catalog, that central piece?
Similar pattern. The data platform lead is often accountable for designing the overall structure, how catalogs and schemas are organized. Security and compliance is there. Accountable for ensuring crucial features like lineage and audit logging are properly enabled and configured.
Who gets consulted?
Teams like data science enablement might be consulted on the catalog design to make sure it works well for finding datasets for model training. Business units might be informed.
Okay. Let's take identity and access management. Who owns ensuring people only have the access they need?
That typically falls squarely on the security and compliance team. They are accountable for validating that the principle of least privilege is enforced and for regularly testing those access controls.
And why is validating least privilege so important? Again, just quickly.
Because it drastically limits potential damage. If someone only needs read access to sales.csv, they shouldn't have delete access. If their account gets compromised, the attacker's blast radius is much smaller. It's fundamental security hygiene.
Makes perfect sense. How about the machine learning lifecycle?
Here, the data platform lead might be accountable for setting the standards for how models get deployed safely into production. The data science enablement team, or individual data scientists, would be responsible for developing the actual experiment templates, training the models using data like sales.csv.
And security again.
Accountable for validating the security and compliance aspects of the model training data, the stored models, and the deployment process.
Okay, one more, the overarching governance and compliance itself.
The security and compliance team is generally accountable for validating that the whole platform and its processes meet external regulatory requirements, GDPR, HIPAA, etc. But here's a really important nuance.
Oh.
Business unit leads are often responsible for conducting periodic access reviews within their own teams. They know their people best.
So it's not just IT or security checking boxes.
Exactly. It becomes a shared responsibility. Business leads are informed on the policies, but responsible for ensuring they're followed correctly within their domain.
That shared model seems key. So using RCI really clarifies who does what, avoids confusion, and ensures someone is truly accountable for every critical piece of this sales.csv journey. It shows how all these teams have to collaborate.
Couldn't have said it better myself.
Yeah.
It's essential for making these complex systems work reliably and securely.
So let's try and wrap this up. We've followed this seemingly simple sales.csv file on quite an epic journey.
We really have.
And what it demonstrates is this incredible integration, right? Secure ingestion, strict schema enforcement, deep governance, operational smarts, all woven into one single cohesive pipeline. It's anything but simple underneath.
It really isn't. And the benefits that come from standardizing this kind of lifecycle are huge. First off, you get real data integrity and trustworthiness.
Because of the validation, the versioning with Delta time travel, the lineage tracking.
Exactly. You always know where the data came from, what's happened to it, and you can rely on its accuracy.
Benefit number 2.
Robust security and compliance. Using that central governance with Unity Catalog, enforcing fine-grained access, encrypting data everywhere. It means sensitive data, like sales figures, are properly protected at every single step.
Right. And the third big outcome.
Operational efficiency. Things like auto-scaling clusters, so you only pay for the compute you use. That cost attribution, linking data costs directly back to business value. Continuous performance optimization, it all makes the process lean and effective.
Leading to scalable consumption.
Scalable consumption and enablement for analytics and ML across the whole company, which ultimately fuels innovation.
So by having this standardized lifecycle, teams can confidently deliver these high-quality, governed data products, which means better, faster, more reliable decisions everywhere.
That's the goal, empowering the entire organization.
Which brings us nicely to a final thought for you listening. Think about how understanding these, well, seemingly technical data journeys can actually empower you.
Yeah, maybe to ask better questions about the data you see, make more informed decisions, maybe even spot new opportunities based on how data flows in your world.
What other hidden journeys, like the one sales.csv took today, are happening all around us, shaping our world in ways we don't normally stop to consider?
It's definitely something to think about. What parts of this journey stood out most to you? Any surprises?
We'd genuinely love to hear your thoughts. Thanks for diving deep with us today.